Hello, scientists. This is Mr. Miller. I want to talk today about the water cycle or continue our discussion of the water cycle. And hopefully, the essential question or what we really need to understand is where does our drinking water come from? And a realization that the supply of drinking water is very limited. And since it's limited, it helps determine where life exists on our planet. So if we come down and talk about the water cycle, we've said the water cycle is called a cycle because all the water we have on our planet is the same water that's existed here since the beginning of our planet over 5 billion years ago. And that water has been used by living things throughout the history of our planet. And when living things die, they give up their water that they stored and used. And all the water that exists on the planet is constantly being recycled, purified, so that it's great drinking water for all life today. So water is constantly being cycled between the atmosphere, the oceans, and the land. And remember, the oceans are the bulk of the surface of the earth is ocean. And so that processing, that converting that liquid water into gas and the gas back into liquid so it falls and can be stored in the ground or used by us, that's what helps sustain life on our planet. And when we look at other planets, they're not hospitable or they're not habitable because they don't have enough water or water in the form that is usable by us. So this is just a depiction of the water cycle, and we'll talk in great depth about this. But if you start out and look at the oceans, you look at the ground, water is constantly evaporating. It goes up into the atmosphere as a gas. In the atmosphere, it cools or condenses, and then gravity pulls it back down in the form of precipitation. And this is constantly happening. You know, if you live in Seattle, you realize the water cycle happens every day because it seems like it rains there. Here in Moses Lake, we get less rain, but we certainly do see the rain, and we see the effects of that rain, that clean water on life here. All right. So we could describe then the water cycle as the movement of water between the atmosphere and the surface of the earth. And we know the surface of the earth is mostly oceans with some land. 30% of our earth's surface is land. And we know that rain, snow, ice, and hail fall to earth. And that's a result of gravity pulling it down into from the atmosphere. How does water change from a liquid, gas, or a solid? Well, we call those changes in state or phase. And water is found in 3 states or 3 phases on Earth. It's either found as a liquid, as ice, or as a vapor. So it's a liquid, solid, or a gas. Now, how does matter change from a liquid, solid to gas? Well, we've talked about that, and we said it's a cycle. And all I have to do is either add heat or take away heat. So let's take a second here. Phases refer to any kind of matter. We're matter. The tabletop you're sitting at, your computer's made of matter. And there's only 2 things in the world, and that's matter or energy. Okay? And all matter on our planet exists as a gas, liquid, or solid. And it has a preference based on temperature of what form or phase it will take. To change the phase, I either have to add energy, and the energy we're adding is heat, or I have to take energy away, which means I'm going to cool it. So we can take liquid water and cool it and turn it into an ice cube. Likewise, I can take liquid water and heat it and have it turn into a gas, and I can actually go from a solid right to a gas. So again, a cycle. How much water reaches the atmosphere? Well, there's a lot of water that is evaporating. And you would think that I would have to add enough heat so that the ocean would boil to release its water. But in truth, it doesn't take that much energy. And I have individual molecules of water leaving the ocean. And since the ocean is the majority of the surface of the earth, 90% of all the moisture that enters the atmosphere comes mostly from our oceans. And it comes there from evaporation. And we know even on a cold day, if it rains outside, then all of that will eventually evaporate and be gone even on a cold day. If you look at the snow we had this morning, the snow hit the ground, it froze, and as it started warming up, it's certainly not at boiling point or 212 degrees Fahrenheit, but if you go look out on the road, all that snow was converted into water, and most of that water has evaporated or run through the storm drains, and now the streets are clear again. So that's how all that water gets up into the atmosphere. Now, once it's up in the atmosphere, we have another phase change. Now, we use the word evaporation, and if I get rid of the first E and the ation at the end, I see vapor. And a vapor is a gas. And here in the picture, you can see some water. You can see the little fog, and that is what actually evaporating, turning into a gas. Because the air is cold, you can actually see the cloud formation or the condensation of that liquid water. So we're witnessing two phase changes here, from a liquid to a gas, and now it's starting to cool and it's going to turn back into a liquid. Okay, and it's all based on heat, and all the heat for the water cycle, all the energy is driven by our sun. So what happens to water in the atmosphere? Well, water, because it's a gas wants to go everywhere. So it goes and it starts to rise because it's lighter than air. So the air is sinking down below it and the water vapor is going up into the sky. Now, as I get higher into the sky, the atmosphere gets cooler and cooler. So now I'm starting to cool off the water vapor. I'm taking energy away, and that causes those molecules of water vapor to start to come and stick together because water is very sticky. And as these water molecules start collecting with more water molecules and joining, pretty soon they get heavy enough so that now it's not lighter than air because it's bigger, and gravity's going to pull it down to the earth. Now, some of that liquid water is going to fall as a solid because the air temperature is so cold that it's either going to form hail or sleet or ice or snow. Some of it's going to come as a liquid and fall all back to earth. So again, if we look at the water cycle, we see we have arrows coming from the ocean, so that's going up. I have evaporation, evapotranspiration from plants and animals. I have evaporation from fresh water, like lakes and ponds and rivers and streams and creeks. And I have water coming off of the soil. And all of that is going to the atmosphere, building these massive clouds. And the clouds are just water droplets, water vapor. And as they get heavy, it flows back down to the earth. So let's take a little timeout break here and talk about water vapor. Where does the water vapor come? Well, we know it's a process called evaporation, where a liquid becomes a vapor or a gas. And depending on the gas, if it's lighter than air, it's going to rise up into the atmosphere. As it rises, that water vapor condenses. Condenses means to come together. It doesn't have enough energy to keep the molecules apart, so the molecules would rather be together. And now it gets big enough that it's forming clouds that are reflecting light. So now I can actually see the water vapor in the air, and we call those clouds. And as the clouds condense, the water vapor in the cloud condenses, again, it starts to change color, and it starts to rain or cause precipitation. And remember, precipitation comes in many forms. It depends on what the local conditions are, what the altitude is, what the current temperature, wind speeds, all those different things that are reported on the nightly news for weather. So we talk about the opposite of evaporation. Evaporation is a liquid going into a gas. Condensation is just the reverse, a gas going into a liquid. And I do that by cooling. Evaporation, since it's the opposite of cooling or condensing, I have to add energy. So as those droplets start to form, they get bigger and bigger. They start sticking together, and eventually gravity is going to pull them down to Earth. So the millions of little droplets, the water that's suspended in the sky in the clouds, if it's warm enough, they have enough energy, the clouds just pass on by. But as I increase the amount of water vapor, increase the amount of clouds, and cause it to cool or change pressure, now the water droplets start to form, and now I have condensation occurring. And if it is cool enough on the ground, those clouds will actually extend down to the ground and cause something called fog. And of course, the last thing we're going to talk about is precipitation. And when the temperature and atmospheric pressure are right, all the small water droplets that make up the clouds start to glue themselves together. The droplets get bigger. Eventually, they get big enough to fall. And we have all been in a huge downpour where the water, big droplets are falling very fast and it's hard to see. And we've seen the little misting rings. And that all depends on temperature and atmosphere and local conditions. That's why Moses Lake has a different precipitation pattern or rainfall than, say, Spokane or Seattle or other parts of the world. So what I want you to do in your Google Science Journal is I want you to explain briefly what is driving the water cycle. And you should cover condensation, evaporation. You should be able to tell me if it's heating or cooling. Okay? And then I want you to think about what happens to all that precipitation. Where does it go? Well, some of it's going to fall right back in the ocean because the ocean is 75% of our planet. Some's going to fall on land, but if it falls on land, what happens to it? So write down your thoughts, and then make sure on Friday you share your science journal with your teacher. All right, we'll talk to you later.